Hello students, welcome you all in the online platform of Sharda Vidya Mandir. Today we are going to learn the first chapter from the syllabus of class 9, that is number system. In your earlier classes, you have learned about the number line. The number line which contains all the real numbers, that is called real number line. And in the middle of this number line there is 0. In the middle of this number line there is 0, and in the right side all the natural numbers 1, 2, 3, 4, 5 continues up to plus infinity is there, and in the left side all the negative integers -1, -2, -3, -4, it continues up to minus infinity. All these numbers together are called set of integers. And so we are interested now to know about the numbers which are there between these consecutive two integers. Suppose let's take 0 and 1. Between them some fractions are there, 1/2, 1/3, suppose 3/4. So as you know that all the proper fractions, they lies between this 0 and 1. This boundary 0 and 1, they lies between this boundary, and 1 and greater than that there are the fractions which are improper. Okay, so the fractions are there between two consecutive integers. Now all these numbers together are called rational numbers. So real number contains the rational numbers. What is rational number? That integers along with the 0, negative of the natural numbers and natural numbers all together is the integer, and along with the fractions all together are called rational numbers. These all are the rational numbers. And some other type of numbers are also there in the number line, real number line. They are called irrationals, which are not rational. So some other numbers are there which are not rational. So let's know about the rational number first. Rational number. So what is the definition of rational number? The definition of the rational number is a number if it can be expressed in the form of p by q, where q is not equals to 0, since nothing can be divisible by 0, so p by q you have to write where q should not be 0, and the GCD of p and q should be equals to 1. What is the meaning of GCD? Greatest common divisor, which is nothing but the HCF, highest common factor. So the GCD or HCF, you can say the HCF of p and q should be equals to 1, and only if any number satisfies these two conditions, then they are called rational number. For example, if I take 3/4 or 5/7, where 3/4, 3 and 4, obviously 4 is not equals to 0, so the denominator is non-zero here, and here also 7 is non-zero, so both are satisfying the first condition. And 3 and 4, their GCD is 1. 5 and 7, there is also the GCD or HCF 1. So they are the unique rational numbers, and we can express these numbers in the number line. For example, 3/4, it is obviously less than 1, so it should be here between 0 and 1. And 5/7, it is also less than 1, so it should be between 0 and 1. And if I take 7/5, and it is greater than 1 but less than 2, so 7 should be there in between 1 and 2. Okay, this way we can express the rational numbers in the number line. Now we want to learn, when we are learning about the irrational numbers, so we want to learn something about the numbers which are not rational. The numbers which are not rational, they are called irrational numbers. Okay, they are called irrational numbers. The numbers which are not rational. This is a very basic definition for the irrational numbers, the numbers which are not rational. But there is another definition is also available for irrational number. The number whose decimal expansion is non-terminating as well as non-recurring, they are called irrational number. We know that the decimal expansion of any fraction or any number is of two types. Either is terminated or it's non-terminated. That means you keep dividing, keep going on dividing, but it will not finish, the division will not finish. Like 10 by 3 suppose. So if you divide 10 by 3, 3 is a 9, every time you will get 1 and it will go on 3.33333. It will never terminate. So this type of divisions are called non-terminating division, non-terminating decimals. Okay, and if you get a same number or a same group of numbers, suppose 3.123, you are getting repeated. The numbers are repeating again and again, 123, 123, 123 after the decimal point. So this is called recurring decimal, and this is also recurring decimal because the number 3 is it's repeating again and again. So it can be written in the form 3.3 recurring, and here also 3.123 then recurring between these two numbers, these three numbers. Okay, so these are called recurring, but recurring decimal. And if that is recurring decimal, then also it is rational number because it can be expressed as the form P by Q, 3.3, and recurring it can be expressed in the form 10 by 3. So it is also rational number. So which one is not rational? That one, the number which is non-terminated as well as non-recurring. So no repetition will be there. Every time you will get new digit, new set of digits you will get. So that is called the irrational number. The definition of the irrational number is the numbers whose decimal expansion is non-terminating as well as non-recurring. They are called irrational numbers. Now few examples of irrational number we want to know. Since we are saying that irrational numbers are also there in the number line, so but we cannot see here which are the irrational numbers. All I have written here all the rational numbers. So the irrational numbers, the example of the irrational numbers are root 2, root 3, root 5. These are the examples of irrational numbers which I have not given in the number line till now. Now only this type of numbers are there in the irrational number? No. Some few other types of irrational numbers are also there, like the gravitational constant, the number pi. These are also the irrational numbers. Okay, now we want to find the irrational numbers in the number line. 0 is here, 1, 2, 3, 4. The negative parts are also there in the left side, but it's not required now. Suppose first we want to plot the number root 2, which is irrational. We want to plot it in the number line. So where will be this root 2? Let's take the 0 as our point A, and let's take 1 as our point B. So we have taken the length of 1 unit. Okay, and at the point B we have drawn one perpendicular of length 1 unit once again. 1 unit. Okay, and we have given the point as C. Now if I join A and C, so ABC will be one right angle triangle where the right angle is the angle B and AC is the hypotenuse there. Now height is 1 unit, base is also 1 unit. So what will be the hypotenuse? OC is equals to root over height square plus base square, which is nothing but 1 square plus 1 square, so it is root 2. So OC, this distance, this length will be root 2 unit. If I take the base to be 1 unit and the height to be 1 unit, so the hypotenuse will be root 2 unit. Okay, now this hypotenuse OC is of finite length and which is equals to root 2. So we can, using one compass, we can take the measurement of the OC length and pointing the compass in our 0 point, we can take the measurement of that length on the number line. That is called taking the projection. So we want to take the projection of the length OC on the number line. Let's give it P. So this OP distance is your root 2 now. This OP distance is your root 2 now. So the point P is the root 2. Point P is the root 2. As we know, the distance from 0 to 2 is 2 unit. That's why the point is allocated 2. This distance between 0 to 3 is 3 unit. That's why it is the point 3. So if the distance between 0 and P is root 2, so P is the point root 2. P is the point root 2. Okay, this way we can plot the irrational numbers on the number line. Let's take root 3. Let's draw the root 3. 0, 1, 2, 3, 4. Here what you have to do? You have to take the root 2. Now we know where our root 2 is. It's between 1 and 2. And the approximate value of root 2 is 1.414. So it should be between 1 and 2. Since the approximate value of root 2 is 1.414. So now we have to take the base as root 2. We have given A and B. And we are going to take the height as 1 unit. Suppose this is the 1 unit and we are giving the end point as C. Now if we join O and C, then OC is the hypotenuse, and what will be the value of OC? Is equals to root over AB square plus BC square, which is nothing but root over root 2 square plus 1 square. So it is root over 2 plus 1, root 3. So OC we have got root 3 unit. And again it is of finite length. So we can measure using our compass the length of OC. And again we can take the projection. We can take the projection of OC on the number line. So where it will meet the number line, that will be the point root 3. So this way we can find all other irrational numbers. Now let's see the exercise. From your NCERT book, the first exercise is 1.1. It is given. First question, is 0 a rational number? Yes, obviously we have discussed that 0 is a rational number because 0 can be written in the form 0 by 1 or 0 by 2. Anything could be written, and which is equals to 0. We didn't change the value, and here Q is not equals to 0. Here also Q is not equals to 0. So 0 can be written in the form P by Q, where Q is non-zero, and the HCF of 0 and 1 that cannot be said here. And Q is non-zero here, so it is of the form rational. So it is a rational number. 0 is a rational number. And the question is, can you write this one in the form P by Q? So you can write it in the form P by Q. And in the definition, it was mentioned that Q should be non-zero, but nothing was mentioned for P. So P can be 0 and Q should be non-zero. And we have taken Q as non-zero here. Now the next, number 2, find 6 rational numbers between 3 and 4. Here I want to discuss this question. There are many ways to find the rational numbers between two consecutive integers or two consecutive rational numbers. It is given 3 and 4. So we can write 3 and 4 as 3 by 1 and 4 by 1. Thus it is the rational number. And if we have to include 6 rational numbers between them, so we are going to multiply both of them by 7. So it is nothing but the equivalent fraction of 3 by 1. So we didn't take any new rational number. It is nothing but 3. It is equivalent. And 4 also we are going to take 4 into 7 by 1 into 7. So 7 we have multiplied in both the numerator and denominator, so it is adjusted. So nothing new we have written, which is nothing but 21 by 7 and 28 by 7. Now we have to include rational numbers between them. So 21 by 7, greater than that we have 22 by 7, but it is less than 28 by 7. So definitely 22 by 7 is there between them. And again 23 by 7 is also there between them. 24 by 7, 25 by 7, 26 by 7 and 27 by 7. These 6 numbers will be there between them. So it is the best way to find out the 6 rational numbers between two consecutive integers or two rational numbers that will be given. So we can do that. Let's take another example here. Suppose 3 by 2 and 5 by 4. These two fractions, these two rational numbers are given to us, and we have to find 3 rational numbers in between them. We have to find the 3 rational numbers between them. First of all, we have to convert both of them into like fraction. How to convert them into like fraction? First you do the LCM of 2 and 4. And we know how to convert them into the like fraction. Okay, so we have converted it. 6 by 4 and 5 by 4. And 6 by 4 is nothing but 3 by 2. It is not a new rational number. It is same only. It is equivalent. So 3 by 2 and 6 by 4 are equivalent. So we have now 6 by 4 and 5 by 4. Now we have to include 3 rational numbers between them. So we are going to multiply both the numerator and denominator by 4. We are going to multiply both the numerator and denominator by 4. So the numbers became 24 by 16 and 20 by 16. Every time you will see that, you will notice that there you can write only 3 numbers between them. As you have multiplied by 4, so you will get only 3 digits between them. Okay, so 21 by 16 can be written here between them, 22 by 16, 23 by 16. Now this will follow the greater than sign. So these are the 3 rational numbers that can be inserted between these two given fractions, between these two given rational numbers. Obviously fractions are also rational number, so both are same. Next question. Next, give 5 rational numbers between 3 by 5 and 4 by 5. This one you can do in your home, same type. Next, true false. Every natural number is a whole number. Every natural number is a whole number. Obviously all the natural numbers are whole number, because natural number including the 0 are the whole numbers. So every natural numbers are whole number. Every integer is a whole number. Definitely it is not, because whole number is a part of an integer. So other integers are there which are not whole numbers. So the -5, which is not whole number. So every integer is not the whole number. Every rational number is a whole number. This one is also false, because some rational numbers are there which are not whole numbers. Whole number is a part of rational number, but all the whole numbers are not rational. All the rational numbers are not whole numbers. So let's start next exercise 1.2. First question is, every irrational number is a real number. You have to say whether it's true or false, and you have to justify your answer as well. So first one is, every irrational number is a real number. Yes, obviously it is true, because we have said earlier that irrational numbers are the part of a real number, and a real number contains both rational and irrational, and just you write irrationals are the part of real number, and irrational numbers can be expressed in the number line as well. So this is true. First one, it is true. Next, every point on the number line is of the form root m, where m is a natural number. You notice this one, m is a natural number. Okay, so every point on the number line, in the number line there are many points, 0, 1, 2, as well as there are 3 by 2, 1 by 2. Okay, so if I take 1 or if I take 2, that can be expressed as root over 4, root over 2 square, root over 2 square, that is root over 4, where 4 is a natural number. Obviously it is true, but 3 by 2 if I take, that I have to express that one as root over 9 by 4, but 9 by 4 is not a natural number. So if I want to say every number can be expressed of the form root m, where m is the natural, that is false. Every number cannot be expressed as the root over of a natural number, so it is false. Just you give this counter example as your justification. This counter example as your justification you give. So number 2, it is false. Every real number cannot be expressed in the form of root over of natural number. Next, number 3, every real number is an irrational number. No, it is not true, because rational numbers are also there. Just you give one counter example for that. It is false. Again you read the question, every real number is an irrational number. So for counter example you have to choose one real number which is not irrational. It's a very simple, -4 you choose, or you choose 5. They are not irrational. They are not irrational. So number 3 is false. Just counter example is sufficient for the justification of your answer. Next, number 2. Are the square root of all positive integers irrational? Are the square root, we have seen that square root of 2, square root of 3, square root of 5, the square root of these numbers are the irrational numbers, where these numbers are the positive integers. Okay, so a natural question should come to your mind, that the root over of every natural number, is it irrational? Root over of every natural number, is it irrational? The answer is no. It is not true. Why? Let's take root over 4. It is plus minus 2. Whether it is plus 2 or it is minus 2, both are not irrational. Let's take root 9 plus minus 3, root 16 plus minus 4. So they are not irrational. So all the time, every time, it is not true that root over of any natural number will be the irrational number. They may be rational as well. In extension, I want to say root over of a prime number is always irrational. Root over of a prime number is always irrational. You have seen, you may notice this one, 2, 3, 5, next irrational will be root 7, root 11. So all of the prime numbers I have taken. So root over of prime numbers are the irrational numbers. And if I add two irrational numbers, then the resultant will be another irrational number. If I add this type of irrational numbers, then also the resultant is irrational. That is, if I multiply some rational number with one irrational number, the resultant will be the irrational. And if I multiply two irrational number, then also it is irrational until we are multiplying the same irrational number with each other. Until we are multiplying the same irrational number with each other, only that case you will not get the irrational number. Otherwise, if you multiply two different irrationals, you will get another irrational number. Or if you add two irrationals, or if you multiply the rational with the irrational number, you will get the irrational number only. Okay, next question. Show how root 5 can be represented on the number line. Okay, fine. Number 3, we have to express root 5 in the number line. We have taken 0 here. The negative parts I am not showing here because we don't require. 1, 2, 3, 4. Okay, let's take 0 as our point A, and let's take the length of the base to be 2 in it. So at point 2 I am giving B, and at point B we have to draw the height that is perpendicular of length 1 unit. So at the end I am giving C. Now let's join the hypotenuse OC. So what will be the length of OC? It's root over of AB square plus BC square, which is nothing but root over of 2 square plus 1 square, that is 4 plus 1 root over 5. So OC is the length root over 5, and if I take the projection of OC on the number line, so it will be the point root 5. It will be the point root 5. So you can take the help from of the compass to draw the projection here, and obviously you will draw the number line using a ruler only. So this much only today. Next day we will go to the next exercise, and we'll learn more things about irrational number. We'll learn the decimal expansion and many other things. So till then, you practice these two exercises and stay in your home, stay safe.